Good afternoon, everyone. My name is Saif Alramahi from Birmingham City University, and today I'm going to be presenting my paper titled Towards a Semantic Ontology for Occupant-Centric Building Control, which sits part of my PhD on improving the adoption and implementation of occupant-centric building control systems and automation systems. Cool. So for years, we've invested in building automation systems to manage and run our indoor environments, everything from heating, cooling, shading, and lighting with minimal human input. And the promise was very straightforward. It's to better the energy performance and indoor comfort simultaneously. In principle, with these systems, buildings should become more energy efficient and comfortable for the occupants that live within them in the same time. However, evidence shows that automation is being rejected from the occupant's perspective, with studies showing that 88% of occupants override automated blind controls. Windows open in conditioned offices up to 49% of occupied hours, and around 78% permanently disable automated lighting controls in their workspace, which says something about building automation systems. And the main reason behind these systems being rejected by the occupants is because they operate on fixed schedules and average thresholds rather than on individual occupant needs and preferences. So, researchers got tired of this basically and said, well, what if we come up with a way to get our buildings to adapt to our needs and preferences, and in the same time, save energy. And they came up with this idea called occupant-centric building control, which, very big name, but in a nutshell, it means the intelligent or the dynamic control of building systems based on real-time occupant information, such as presence, preferences, and feedback, to simultaneously optimize comfort and energy performance. And the way it works is pretty simple. An OCC system would sense and collect occupant data in real time. It would model the occupant needs and preferences, and then it would act by adjusting building systems to cater for that occupant. However, the problem with OCC is that its implementation and evaluation is difficult, as it requires connecting data from a lot of disconnected domains. And that includes the physical environment, the occupant and preferences, feedback and interaction, control and automation, the systems, and of course, the evaluation and outcomes of those results. And what this problem does is that it creates three barriers. So we get, no shared vocabulary between these domains within OCC, no defined relationships of how they connect together, and a very limited interoperability between studies and implementations of OCC. Therefore, this what it does is, it's basically, we cannot tell whether a control action from an automated system improves comfort, if it reduced energy use, if it's met a standard, or fails an occupant. And this leads to, no cumulative knowledge of our work on these smart systems and, our findings of how they cater for the occupants, and ultimately no scalability in different buildings and different spaces. So a very viable and interesting approach here is a semantic ontology, And you might ask, well, okay, why does OCC need a semantic ontology and how would that work? And basically, a semantic ontology here for OCC would create one shared vocabulary for all the OCC field constructs, defined relationships between the different domains that I've showed recently, previously. And it's designed in a way that's, it's interoperable, and, data and findings can move around studies and different systems rather than being locked by one platform. Now, there are existing ontologies in the space. This is not a new methodology for, or a new method for the space of, IoT and smart automation systems. So there are existing ones. Saif for building is an ontology that defines building topology and devices. There's SSN, which is very focused on sensor and actuator observations. OFO, occupant feedback ontology, which is all about occupant feedback and how it relates to the space a person sits in. And then there's more around occupant behavior and building performance. However, the issue here is that each contributes very useful concepts, but in their own kind of domains. And there's no framework that connects all of these domains that occupant-centric control would require. So we set out to build OCCO, or occupant-centric control ontology. You could scan the QR code, which would take you to the ontologies page and show you, more about it. And in a nutshell, what OCCO does is it brings the 5, OCC domains together in one framework based on the concepts that we've identified in the literature. So that would be, of course, we've also developed it using LOT. So that's a ontology engineering methodology, which stands for linked open terms. And we've used the visual comfort and lighting control use case as a proof of concept for OCCO to apply on. And what OCCO does is it brings the domains that we mentioned all together in one picture. And that's, our physical environment, so concepts and constructs such as building zone, light sensor, lighting devices, the occupants and preferences, the occupants and how they link and how they link or how they are related to the visual task that they're doing and their preferences of light levels and chronotype. The feedback and interaction of the occupant, so everything from complaints to comfort scores to override actions over automated systems. Control and automation, so that's your control strategy that's being applied in a space, controller, actuation, and a time of action. And evaluation and outcomes, which is the result of whether a control strategy is effective for a place or for an office. So, okay, you might ask, well, how does this work in practice? And for us to test this, we basically came up with some functional requirements of, okay, how does an ontology fix what's happening within OCC or within the field of smart automation systems? And one of those questions were, with OCCO, we could ask which building spaces meet the comfort standard but received negative comfort feedback from occupants. So let's take a scenario, for example, where we have an open plan space and there's a lighting strategy being applied to that space. And we've got a light sensor. It's pretty small, doesn't show, but it's saying that it's reading 620 lux. And you've got 2 occupants reporting that they're not happy with the lighting levels. Now, this looks, very fine because based on the applicable standard of that office, it's fine because the control strategy is meeting the standard. However, with OCCO and with integrating the objective side of the occupant's experience, and how subjectively they feel in real time, we can tell that yes, it does meet the standard. However, the occupants remain dissatisfied, and we can flag it for review. For verification and results, we did this in 2 parts. So functional testing that included another 9 real-world questions from the OCC literature, just like the one I showed you, and these cover everything from control automation, occupant preferences, performance evaluation, and the trade-offs of comfort and energy in one space. And we verified this using synthetic data generated from large language models for each of the questions, which were manually reviewed, and all of them were answered with the expected results. As in for the structural testing, we did this in 3 parts. This is the, we did the logical consistency, checking the contradictions within the ontology's model through Protégé's Hermit's reasoner. We did design quality, which was checking the model using OOPS, a pitfall scanner, which basically is designed to check for common flaws within ontology structures. One issue was found here and fixed. And then open data, we use open data standard, which is another tool called FOOPS, which basically verifies the ontology based on the fair compliance. And that's, an ontology being findable, accessible, identifiable, and reusable, and it scored 88%. So why does this all matter, and what's next? So I see it in 3 different pillars. For the researchers, what OCCO does is it gives them a shared way to compare findings across studies. For facility managers and building owners and people overseeing these automation, these control strategies in spaces, they get a way to query and understand the relationships between comfort, subjective experiences of the people in the spaces, and objective, findings of those spaces. And that can inform for real operational decisions. As in for the system vendors, this gives them a kind of like a standards aligned structure to build on, rather than starting from scratch and working in silos. Our next steps is real-world validation with domain experts and real occupant data, of course. Doing a few applied use cases with OCCO, so integrating it with existing IoT systems, digital twins within smart offices, and extending beyond lighting into other comfort areas such as heating, cooling, noise, and more. Thank you. Any questions?